So in this video, we're going to kind of get a page of notes that will help us with the process of sketching the graph of a rational function if we're given the equation of that rational function. So in order to sketch it, we have to determine all of the following. First, the domain. So we take that function and we set the denominator equal to 0. And we solve it. And then all of those solutions to the denominator being set equal to 0 are the excluded values. Then on to wholes and vertical asymptotes. We've already gone over this. Remember, we're going to factor both the numerator and denominator and reduce to lowest terms. So if we can reduce, those factors are of interest to us for the wholes. So any factor that's common to the numerator and denominator are the location of wholes in the graph. We're going to set those factors that are common equal to 0 to solve for x. Those are the x values of the wholes. And then we're going to plug those x values into the reduced function to find the corresponding y value of the whole. Now remember, this is not in the domain of the function, so it would just show us where on the curve that the whole appears. It gives both coordinates that way. And then finally, set the denominator of the reduced function equal to 0 to find any vertical asymptotes. And of course, when it's already factored, you can usually just read those solutions. Now from here on out, let's just talk about the analysis through the lens of the reduced function. Horizontal and oblique asymptotes. So we're going to find any horizontal or oblique asymptotes by comparing the degrees of the denominator to the degree of the numerator. That's what we went over in the last video. We're going to determine whether the graph intersects the horizontal and oblique asymptote by setting the function equal to 0, or sorry, not equal to 0, equal to the either horizontal value or the oblique asymptote equation. Let's see if we can find intersects. We haven't done that yet, but we'll see that soon. And then intercepts. Well, we know how to find x and y intercepts. We first substitute 0 for x to find the y-intercept, and then 0 for y to find the x-intercept. But really, for the x-intercept, we just have to look at the numerator, the zeros of the numerator. Now the shape and location of all the branches. Those are the different curves that are caught between asymptotes. So plug in the x values between the vertical asymptotes, wholes, and intercepts to find ordered pairs on the graph. So there'll be a branch on both sides of the vertical asymptote. And the branch will be located either above or below the horizontal or oblique asymptote, but it will never be in both places. So either above or below the horizontal oblique asymptote, but never in both places. Why? Because it wouldn't be a function.